This is my fourth vlog on drills. I'll look at the wicket drill, which is used to improve sprinting. There are several variations of the wickets drill used to target different areas of the sprint, namely the acceleration phase and the max velocity phase. In this vlog, I'll focus on the wicket drill to improve acceleration phase of sprinting. This is a quick overview of my vlog. I'll start by going over a few technical points of acceleration, then I'll analyse the wicket drill. I'll then look at an athlete run this drill and compare this to his normal sprint. I'll then compare his sprint before and after the drill. Then I'll provide a summary. 75% of total acceleration is achieved within the first 7 steps. Stride length should increase as well as the stride frequency. Ground contact time should decrease with the acceleration phase. A piston action of the legs allows a low heel recovery. A low heel recovery is also important as this reduces the time to recover the leg. Shin angles of around 45 degrees enable maximum displacement from the blocks. The torso should match the shin angle on foot strike with a straight line head to toe. The torso is in front of the centre of mass, whilst the limbs push behind, causing forward rotation of the centre of mass. Exaggerated arm actions counterbalance these extreme forward rotations, propelling the body forward. Ankle should be stiff at 90 degrees. This is my athlete sprinting. As you can see, he has relatively sound mechanics with good ankle and torso angles. He has high knees and a relatively low heel recovery, and a good exaggerated arm action. This is the wickets drill. The wickets drill is an obstacle course that forces the athlete to self-organise their posture around. The athlete runs through a series of mini hurdles with an increasing spacing, making the athlete increase their stride length and have a tall posture. This can be run at a max or a sub-max velocity. The drill is designed to improve front-side mechanics and improve stride frequency, as well as increasing force production and the direction of strike. It helps with problems of overstriding and back kicking to ensure that there is a low heel recovery. When using it with beginners, like children, you'll often see them kicking out their feet to the side. Once cued, the athlete would automatically raise their knees. I will now compare my athlete running the wicket drill compared to his normal sprint. From the frontal view of the wicket drill, you can see his knees raise above the line in line with the hips, and in the sprint drill they don't raise as high. Having a high knee enables a low heel recovery. From the sagittal view, you can see the knees are higher in the wicket drill compared to his normal sprint. I tried to represent this by showing the torso and knee angle, but the hurdles made the athlete upright earlier, with an upright torso making the angle larger than the normal sprint, which shows a smaller angle between the torso and raised thigh. Therefore, this drill may be good for increasing the stride length, but it possibly makes the athlete upright too soon so he can raise his feet over the hurdles. Another possibility is that the hurdles were actually too big using the recommended 6-inch hurdles. Maybe if they were turned upside down, this would be a better drill. I also got the athlete to perform the sprint before and after the wicket drill intervention. The left is before and the right is after. As you can see, there is little difference between the two from the frontal view. In the sagittal, you could say there's a slight difference between the stride length. There may be little difference because the drill hasn't been practiced and therefore no new patterns have been learned. Additionally, the athlete has good mechanics to start with, meaning it would be hard to see significant differences. There are definitely limitations with this drill, especially in relation to using this as an acceleration drill rather than a max velocity drill. In my opinion, a run-up may be needed to allow the athlete to have momentum. The feedback from the athlete was that he thought the drill got him upright too quickly. A low position with a shin angle of 45 degrees is important to enable him to build up that speed. Also, I chose arbitrary distances between the hurdles commonly used by coaches. However, I think this needs to be individualised depending on the athlete's stature. In conclusion, I think this drill worked well and enabled the athlete to get his knees high with a low heel recovery. It gives the athlete automatic feedback, and if the drill isn't run correctly, there will be consequences by them falling into the hurdles. However, I think it's important to recognise that although I intended this drill to be for acceleration, it may work better as max velocity with a running lead in. This allows the athlete to focus on those upright positions with high knees and a low heel recovery.